All right, we are live. Cool. So today, or this afternoon, night, whatever time it is for you, we're gonna learn the Go language, and this is completely new to me because I come from a Python and JavaScript background where mostly I've scripted. I've even wrote some Bash, but I would say honestly most of my time in terms of coding has been JavaScript and Python. But all that's about to change. I've heard about this new sexy language called Go from a few different people, and we use it internally at my company. It seems like every software now is written in Go, or at least components of it are written in Go, especially in the cloud, right? Like Docker, Kubernetes, components of Grafana, or like aspects of Grafana are written in it, right? So a lot of tools that are written in Go, and I think it's kind of time that I dive into it. I've been hesitant. I've held off. I've held strong. I was like, Python, I'm never going to give it up. But I realized it's not that great at the end of the day. Python's cool. It's fun, especially if you're doing like data science and data analytics. I think it's extremely powerful. I think when it comes to actual like web development and talking to databases and really trying to scale your applications and build something that's like very production ready, Go is the way to go because it's compiled, right? Python's interpreted, but I also don't really know anything other than that. I've messed around with Go. I don't want to act like I'm coming in like a complete noob, but the way I'm going to sort of handle this stream today is we're just gonna chill. Got some music in the background, but honestly, I'm just going to learn Go from scratch like I would. Now, if you're coming into the stream or if you're watching this and you've never coded a day in your life and you want to learn programming, this stream could be used for you. I think if you're already advanced and know Go, then this is probably not going to be the best video for you. Maybe in like a few weeks when I come back and and I'm just been using Go for weeks, maybe you could learn something from me. But I think honestly it'd be really great if people join this and I got to learn from you that already know Go, because I don't. Right, so there's gonna be a little bit of humility, a lot of banging my head against the wall, a lot of trying to figure it out, but I think it's gonna be fun. So in that case, I think the easiest way to install Go, if you open up your terminal, is just to do brew install Go. And if you don't have brew, you can just go to homebrew. If you're running Mac, of course, or Linux. If you're running Linux, you can also use homebrew. If you're running Windows, then you're sort of shit out of luck, and I think you should figure out. I think you could probably just use like you can probably just use like curl to pull down Go. I'm sure Go installation has a Windows download. Like, yeah, it does. Okay, yeah. So you can just open the MSI file you downloaded. Blah blah blah. Okay, beautiful. So there's a Windows method too, but you just use homebrew. It's very easy. You just run brew install Go. I already have it installed, so you're gonna see that it'll say auto updating homebrew, all that. But once it's done, it'll say it's already installed and up to date on 1.23.2. So let's just clear my terminal. The next thing to do is you're probably gonna want a text editor. So I use Visual Studio Code, and you can see I've already kind of been messing around with Go, like very basically. So there's nothing like too crazy, and we'll just start from scratch. And then also just iTerm. I can make a video about my development workflow or my development setup, but it's nothing special. People have way cooler, more complex setups, but mine's pretty straightforward. Just use iTerm and Visual Studio Code and try to build some stuff. So let's just look at Go as an introduction. W3 Schools is always just like a great way to learn any programming language I've found, just because they really just hammer the basics of like every language. So if you want to learn like variables, functions, classes, different data types, all that stuff, it's really good for that. If you're trying to like build something, I shy away now from watching any tutorials on how to build anything, because I feel like you fall into tutorial doom or this tutorial spiral where you don't really think for yourself. You just do exactly what someone's writing, and you don't actually sit to think about the code they're writing. I think that's the biggest thing with like AI too. A little bit of a rant here, but AI, it'll just spit out the code that it thinks is best based on what you've given it, based on the prompt you give it. And you don't really stop to think. If you're just copying and pasting code, then you're gonna run into software that's crap eventually. I'm sure you can get away with it on very small scale apps, but it also needs a lot of context, right? If you're using an LLM like ChatGPT or OpenAI's models, you have to continuously provide a context, meaning you could spend all day, especially if you work on a larger code base, and just try to provide individual context to certain files, to certain classes, and then eventually you might get to the point where it kind of understands what you're looking to do. But I think ultimately, like if you're trying to do basic stuff, you could use ChatGPT to learn Go. Like we could do it that way. I'm kind of doing it maybe like the 5-6 years ago way, where you didn't use ChatGPT, or not even 5 or 6 years ago, like maybe 2 years ago, right? Like you would do this kind of stuff, and that's how I still learn today. And I just get my hands dirty. I think that's the only way I really learn. I'm not going to learn by just sitting there and watching tutorials and talking about theory. I already know how to code a little bit. Like I'm effective. I'm not like the best programmer by any means, but maybe one day I could be the best programmer. No, I can't. All right, so we have all this stuff, the quick start. I don't really care about that. Let's go into syntax. A Go file consists of the following parts: package declaration, import, packages, functions, and statements and expressions. Okay, that's pretty much any programming language. We'll look at the following code to better understand it. So we actually could try this. So if we go into our terminal, you can create a directory, just do like mkdir. I have this Go with the flow directory. So I created this hello world file, and you can see if I run ls that I have this hello world.go file. So we can literally paste what they have in here. So if we go and just paste this, okay, and run this program, go run hello world.go. And that's how you run a Go program, I learned. Go run hello world.go. And then, okay, we have our print line. In this format, this FMT is a library. So if we look at the format package, right, it's part of the standard library in Go. So you don't have to actually do any like Go mod init, which actually initializes a sort of like a package file, I think. And you could probably learn this more on the Go like manual when you run Go. So you'll see Go mod, and then just do space. Okay, so initialize a new module and current directory. So in this case, like if we look at our Go mod file in this directory, this is storing all of our packages. Like we even have this quote package that I installed. So like let's say I did install something like the math library, right? This is going to, oh, and you don't even use commas in packages. Since I'm using the Visual Studio Code Go extension, which if you go into extensions, you can see I have Go installed. If I'm not actually using something like a package, it'll just get rid of it, which is kind of smart because it doesn't want to take up space, right? If you're initializing a package or importing a package and you're not going to use it, then it's useless. It's just taking up space. So there's no point. But let's say I wanted to do something like format.println, and then I wanted to do like math.pow, and then I wanted to do like 2 to the second power. I would have to then have the math library in here, but you'll see it won't delete this time. So now when I run this, and let's clear out my terminal, I get 4, because 2 to the second power is 4, or 2 squared is 4, right? So now that we have that, we can see we used a library. But you notice I didn't have to do anything with Go mod. Reason being, the math library and the format library or package, I'm gonna have to like change that word in my head too. It's part of the standard library, so you don't have to actually do like Go, what is it? It's like go install. I don't even know. Like, what is install go package? Go get. That makes total sense, right? Like, go get this package for me. So I don't have to do that. It's just automatically built into the Go language when you do brew install. Okay, so now that we understand a little bit about syntax, and it's gonna talk about this in Go, every program is part of a package. We define this using the package keyword. In this example, the program belongs to the main package. Importing format lets us import files included in the format package. A blank line Go ignores white space. Having white space in code makes it more readable. Okay, so it's not actually bad to have white space in your code in Go, okay? Func main, so this is defining a function. So function main, and then we're calling something, which is what runs. Is a function. Any code inside its curly brackets will be executed, aka these two lines, right? Line 5 is a function made available to from the format package. It is used to output print text. In our example, it will output hello world. Yada yada. Cool. Comments. Coolio, comments, multi-line. Okay, so this is how you set a comment. If you just do command backslash, it'll just do a double, or you can just go like that. But if you wanted to do a multi-line comment, you would do like that. This is a multi-line comment, and then you can see when you execute this, nothing happens because this is a comment. It doesn't get executed. It's ignored by the compiler. Beautiful. Like any other language, nothing that fancy. Let's go to variables, and this is the least sexy part about learning a programming language. We're just looking at the basics right now. So like, how do we declare a variable? How do we declare a function? How do we loop over stuff? What are the data types exposed to language, right? All of this is pretty standard, and honestly, a lot of the languages kind of look and work the same. There's just sort of these nuanced differences, like Python. If you're good, you strictly type Python and you declare what data type it is, but a lot of times, like I write shitty code all the time. I'll just say like, variable equals value. I won't say like it's a string, it's an integer, so you don't like run into blocks or they like conflict. But with the var keyword is how we declare a variable. Okay, this is interesting. Var variable name type equals value. So instead of most languages, which are actually the type, so like string name equals Sean, it's actually var name string equals Sean. So like if you work with something like Python, you would do something like, I'll just say like Python, and you could do like this in Python, right? Name equals Sean. In Go, you would do something like var name string equals Sean, and that would make more sense. And then we could do like print that out, for example. So we could get rid of this and say hello name, but you can't do that. So we would keep it like this, Sean. Okay, cool, right? And then there's also another way, which it's saying below with this. This doesn't even look appropriate. This looks like a dick with the dick sign. So if we use this, followed by the variable value, this is also how we can set it. In this case, the type of the variable is inferred from the value. It means the compiler decides the type of variable. I'm curious if there's overhead with this, meaning that if it takes more time for the compiler to infer it. This is actually a good ChatGPT question. Does Go have to, when Go has to infer the type of variable. Is it less performant? When Go infers a type of variable, it does so at compile time, meaning the type is determined before the program runs. The compile time type inference has no impact on performance compared to explicitly declared types, because once compiled, the type of information is fully resolved. Okay, so it might just take a little fractionally longer to compile the program, but once you run it, since that's like the advantage of compiled programs, the code's already been condensed down, placed into a binary file. So when you run it, it's just gonna run. You don't have to worry about it like being slow and performant. It's just when it actually has to compile, that's when it might take a little bit longer. But you can also do this. So let's say we don't want to do var name string blah blah blah. We could just do name equals Sean and then do it like that. Cool. There's got to be caveats here. So it's not possible to declare a variable using that, whatever that is, colon equals, without assigning a value to it. Okay, so you do have to assign something to it. You can't just make it nothing. If the valuable variable is known from the start, you can declare the variable and assign it. Beautiful, 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 beautiful. Okay, so you can have a mixed bunch. So I'm curious if, because there's an effective Go portion of the docs, and I wonder what it says about variables, and if it says you should use one or the other. Is it better to use inferred or explicit variables in Go? And the type is inferred, which is the best practice. I use going lint with the Go format, linter turned on. That's also what I have, by the way. I have a linter and simplify whatever it tells me to. Despite having used Go for quite a while, it still often throws me with what it will and will not infer, so I just offloaded it to a tool and called it a day. Recently, I've come to the conclusion using explicit variable declaration gives more clarity and readability than short. Is it a readability thing? Is that it? I can immediately know where and how to search for type T. Can also minimize duplicate temporary variables and unexpected shadowing. Okay. I'm gonna be honest, I don't really understand what shadowing is. I don't really get what this is. I can also minimize duplicate temporary variables. Expected shadowing, since I know that the name and val is type string in their use. Okay. Alright, I get this. Do whatever you like. There's no wrong solution here. It's more of a matter. Okay, so it's a coding style. So I wonder what my company does. I'll have to ask some of the devs. I would assume for readability, like if I was to write something, I don't know if I would necessarily even care if someone used one or the other. I think that's like, what's the point? Are you really being more efficient by pointing that stuff out, like how you define a variable? Maybe there are edge cases where that is not efficient and you actually run into bugs that way, but I think ultimately who cares? Okay. So there's int string bool, float 32. That means there's got to be float 64 too, right? Go data types. Basic types. Nah, okay, here we go. Int 8, int 16, int 32, int 64, uint, unassigned. So these are, if you don't know programming or haven't programmed before, these are assigned and unsigned integers. Unsigned integers, you'll probably not use them if you're a beginner. I've actually personally never really used unsigned integers, and that's probably because I haven't ran into a complex enough use case to have to. Usually I'll just use int or float 64 because I'm lazy and I probably don't think about it to the nth degree like some engineers do, where they're like, hey, this is only going to use X amount of bits. We should be using this to maximize storage. I don't know. Personally, I feel like if you just use int or float64, you can probably get away with it, unless you have some really hardcore engineers that are going to point that out. There's probably cases that you need to use these, but I would say for now, while we just learn, I'm just probably going to keep it to float64, which is a decimal value, and then int, which is just like 1, 2, 3, 4, 10, 20, 30, whatever. And then there's also complex 128, complex 64. Okay, I don't really know what these even do. So, all right, beautiful. Okay, so we know the types. We know how variables work. You can also declare multi-variables, so with commas. Cool. Naming rules. The variable must start with a letter or an underscore character. A variable name cannot start with a digit, so you can't start with like the number 4. A variable name can only contain alphanumeric characters and underscores. Variable names are case sensitive. Age, and age are 3 different variables. There's no limit on the length of the variable name. Variable name cannot contain spaces, so you couldn't do like full name equals, well, you'd have to do this, Sean Pitts, right? In a string you can, but you can't with a variable. You'd have to go full name or full name, like that. Okay, cool. Camel case, each word except starts it. Okay, so you can either go snake case or camel case. I feel like camel case is the more common. Python, best practice I believe is actually snake case. So I've always used snake case when writing Python. When I write JavaScript, I've actually always used camel case. Constants, I'll use Pascal case, but no, constants I'll actually use all uppercase. I don't really use Pascal case, ever. I wonder if people do. Is Pascal case popular? I feel like camel case is kind of the way to go, so I'll do like full name, but I'll never do like full name, because it just doesn't make sense to me. Like, if I'm doing like proper nouns, if I'm going back to like school days, why would I do full name, which isn't a proper noun? Whatever. Okay. Moving on. Variables, go constants. You can define a constant type. Okay. Can you set multiple constants? Const A equals 1. So you don't actually have to define a type with a constant? Untyped constants are declared with untyped. So you can do untyped constants, but can you do untyped variables? So can you do var name equals Sean? Oh shit, you can. Okay, but you can also do untyped constants. Cool. Okay, so you don't even. So there's little things here that I'm learning. Unchangeable and read-only. Yes, constant variables are read-only and they cannot be changed. Meaning if I have a variable like const name equals Sean, and then I want to say, you know what, reassign this to Bob. Cannot assign to name, neither addressable nor a map index expression. So that's pretty much saying it's a constant. Don't try to change that shit. B 3.14. Okay, I feel like this is a good way to define like a const structure. So if you were to do something like this, right? Like let's say I know things that will never change. So if I say like name string equals Sean, like what else wouldn't change? Whatever, that's good enough, right? I might not have to do var name string, and then I could do, oh, so maybe it doesn't use var in these cases. Oh, okay, so when you're defining it in the, oh, it's because it's a const. Why would you use var? You're already defining it as a const. See, this is the stupid stuff that I don't think about sometimes. Output functions. Function main, var ij string, hello world. So you can have two variables. So we could do like var first, last equals Sean Pitts. And we'd have to go string. And then we could say, this is actually a global variable I'm setting, which is bad practice. Don't set global variables. Name. And I could do first, last. Bingo. So I just printed that out, but this is actually global, which means it's not scoped to a function. If I put it in here, then it's scoped to a function. Coolio. Formatting verbs. You know what's silly about this whole thing? I could do this all day. I love it for some reason. Like the little nuances. It's super fascinating to me. Like even, I don't know why, just like, maybe it's like the wanting to be an expert part of my brain that's like, oh, what if I know every little thing about this language? Eventually I'm gonna hit a threshold, or I'm gonna hit a point where I'm gonna say, you know what, I don't really care about these minute details. Just let me build something, and this is probably gonna happen in like the next stream or two, where I learn a good amount. Like I'll probably get through a lot of this. Probably stream for like another 45 minutes. Formatting. So this is like, I'm hoping to get through the basics, and then we can move on to like advanced topics, maybe in the next stream, maybe tomorrow. Who knows? Who knows when I'm gonna do it? But okay, so we have we're setting a var with untyped variable. Then we're saying printf %v new line I %v in this case prints the value of the variable. So if we do, so we're doing print line right now. Like let's get rid of this. And you'll see math will go kaput. So if we do printf and we want to say %v, we could do first, last, like that. And then you see Sean Pitts. If we want to do with a new line, we pen that, Sean Pitts. So we're saying printf, give us the value and the value of first and last variables, right? Pretty straightforward. T prints the type. So if let's say we wanted to say first name is of type %t, and then we just say first, you'll say yeah, it's because the last string is not being used, so we'll get rid of it. First name is of type string. Coolio. Something about lo-fi beats, it just hits different. You kind of go into like a trance. Go syntax format. What is Go syntax format? So if we do %#v first is of type Sean. Oh, so since it's a string, it's actually just gonna output it like that. It's not gonna say just Sean and like interpolate it. Yeah, okay, coolio. Oh, there's a whole data type section. Bool, numeric, integer, floating point, complex types. What is a complex type? I've never heard of that. And maybe it's because I haven't learned enough languages. We can even do an exercise. So this would be like int, this would be string, this would be bool. Yes. I've never actually passed quizzes. I suck at school, by the way. I do well for myself now, but sheesh, I was bad at school. I could never pay attention. Probably my ADHD brain was just like, yeah, no, this isn't gonna work for us. It was moving too fast. My brain was always moving too fast. I was like, can we just go into the next thing, next thing, next thing? And I got lazy. I was also super lazy when I was a teenager, so I didn't want to do that. Pretty much just wanted to go party. Barbie one bull. Yep. Okay. Cool. Integer. Okay. You know what? This is really bad that my memory is so shit when it comes to program that I forgot exactly what assigned and unsigned integer is. But this is it. Assigned integer can store both positive and negative values, and unsigned integer can only store non-negative values. So honestly, a lot of times I feel like you're gonna use probably unsigned integers, unless, no, that's not true at all. I feel like, why wouldn't you just use signed? What is the benefit of not using ChatGPT? What are the benefits of using unsigned ints versus signed? Performance of certain operations. So this is like a CS lesson too. Unsigned integers do not need to account for negative values. They can store larger positive numbers. That makes sense, right? Because if you have an 8-bit unsigned, it can obviously store more from a range because it doesn't have to deal with negative like a sign does. And 32 ranges from negative. Okay. See, this feels like a lot of theory to me, where unsigned integers can make code more readable by conveying that a value is never expected to be negative. Yes, true. Semantics do play a case here, but I will say, how do you know if you're not going to use a negative number? Maybe if it's a constant, right? Like maybe if I'm saying someone's age, like your age cannot be negative, right? So if I'm going to use an unsigned int, yeah, that makes sense. Because like, let's say I wanted to set a const, right? Let's say I want to say a var, and I want to say var age equals unint or uint 60, just uint. We'll just say uint, and we'll say that's 32, and then we'll say format dot printf. %v is %v years old, and we say first and age. Then we run this. You're gonna see Sean is 32 years old. I'm not actually 32. But let's say we do a negative now. Look at, cannot use negative 32 untyped int constant. How many bugs do you think have been caused by an uint being used instead of an int or assigned int? Love to know. Coolio. I'm not gonna care too much about like whether it's to use 64 bits or 32 bits. At the moment, at least. Do they have unsigned floats? No, they don't. So regardless, floats can be positive or negative. There's no such thing as an unsigned float, people. They don't have doubles. Where are the doubles at? String. Arrays. Here we go. See, people, spend your time. If you're learning programming, spend the time on arrays. Spend the time on whatever these slices are going to be, because they're probably something similar. Spend the time to understand that. Objects, if you're using like Python, or dictionaries if you're using Python, objects if you're using JavaScript. It's important to know those things because you're going to be working with them all the darn time and you're never going to escape them. Because if you do any sort of web development, there's going to be a front end that talks to a back end. The back end is going to grab things from the database or from cache or whatever, and it's going to be in an object notation. You have to reference that object to be able to return back to the front end, and then the front end is going to have to loop over that to be able to view it in the front end application, and then you're always going to be working with objects. You're never going to escape it. Arrays, straightforward. So if you do an array, you don't have to get it up front. So let's get rid of all this. So let's go var dogs, and we'll declare all my dogs in a length of array. Length is inferred if you do 3 dots. If you want to do, like, I have 7 dogs, so we could say data type is of string, and then we'll say values, and then we'll go Remy, Toulouse, Patsy, Walter, Gwen, Millie, Duncan, and then we declare dogs, and then we print them all out. Cool, but then you also can infer the length and not have to say how many you want. Let's see if we do 6 here. If you notice what I did there, if you put 6, you might think that, because I define a length of 6 in arrays usually start at the 0 index, that maybe I'm actually defining 7 items. I'm not. I'm actually only doing, you actually need to declare explicitly how many strings there are. What if you have a mixed bag? This only shows me arrays of 1 type. This is no different. This is how you always access an array item. So if I wanted to get, like, Toulouse, I'd go, give me the first index. If I wanted Duncan, I would say, give me the 6th index. Right? Straightforward. Change elements of an array. Yep, you just override it. So if I wanted to say dogs, 0, 1, 2, that's Patsy equals pat. Format.println dogs. Look at now. Remy, Toulouse, pat, because I overrode it. And you might say, why does any of this matter? It's because we're learning. There's nothing that you gotta you gotta actually care about right now. It's just all about learning. We're just vibing. We're learning. Format array. Array. Okay, so you can also define it this way. What I'm really curious about is how do you define a multi-type array? So if I have strings and integers, do I just not declare a type for it? Meaning, let's say I have, get rid of all the, let's comment this because we might use it again. Let's go var dogs equals, let's infer the length of this, and then let's just go Remy 2. See, it doesn't work that way. So we have to go string int. How do you, can you not have, multi-type arrays? Initialize only specific. Oh, okay, so if I wanted, interesting, so let's say I had 3 items, and they're all gonna be of string, and then I go Remy. I don't get how this works. Why can't I do this with strings? Oh my gosh, it's because I'm supposed to use curly braces. I'm using square brackets. Oh, I'm such a fucking bozo. Remy 2 tours. Let's go. This should work. Does. But what happens if, so what if we do, give me the 0? It'll be empty. No shit. Okay. All right. I don't know if anyone understands this, but what is happening here is you're essentially initializing an object of 5, or an array of 5 integers here. You're saying these are all going to be of type integer, so 10, 20, or 10 and 40 are both integers. However, you're saying in the first index, give me 10. In the second index, give me 40. So you're almost like fixing the position of the item in the array. And then you're saying print the array. But when you do integers, everything that's not initialized is going to default to 0. So that's an important thing to know. Find the length of an array. What bothers me is you can't do multi-type arrays. Can I do multi-type arrays and go? Interface? I don't know about interfaces yet. So we're not going to jump ahead. Go with slices. Create slices similar to arrays, but are more powerful and flexible. Like arrays, slices are also used to store multiple values of the same type in a single variable. Okay. However, unlike arrays, the length of a slice can grow and shrink as you see fit. Okay. Using the data type format, create a slice from an array using the make function. So it looks exactly like an array, but you actually, this is fun. This is fun. So let's go like this. Watch. Format dot print line. And then we're gonna say, no, print f. Dogs is a %t dogs. Watch this. It's gonna say it's an array. Oh, it's a string because it doesn't know what an array is. But if we do it like this, that makes it a slice, but it's still a string. Crazy. Okay. Wait, so what happens if you do... What's the cat? Seven's the cat? Is that because it's the max amount of items in the... What happens if I add a... 8. So it's just telling me the capacity, but the capacity is also tied directly to the length, right? I don't get it, man. Why would you have... I don't see how Go slices are so powerful. And if someone says it's because they can grow and shrink as you see fit, does that mean if I have 7 and now this is an array and then I go dogs 0 equals gone? Do arrays have methods? Go array methods? Like, can I pop something out? Slices are cool, but I don't really get what makes them so great. This is what I use ChatGPT mostly for. Slices are dynamically... Hey, Daniela. Welcome to the stream. You interested in learning Go? You're in the right place. Shrink is needed where arrays have a fixed size that cannot be changed once declared. Makes sense. So if you have an array of size 5 and then it now needs to be 6, you're shit out of luck. You're gonna run into an index out of bounds. If you have a slice, it doesn't matter. But there's got to be trade-offs. It seems like I'm skeptical. C++ has something like this. Vectors. Yeah, what's the difference between arrays and vectors? Okay, let's see this. Are arrays and vectors in C++ the same as arrays and slices in Go? Strong collections of elements, but there are some key differences between them. Go arrays, fixed size, C++, also fixed size, defined with the syntax. Yeah, see, this is what I was talking about in most languages. It's like type, variable, size. Size, type. Or size, yeah, size type. Contiguous block memory and cannot be resized after their creation. Cannot be resized. Are copied. Go arrays are copied by value, creating a separate copy unless a pointer is used, which is similar to Go's array, but is safer and easier to pass around. So there's actually benefits of C++ to Go. Overall, Go and C++ arrays are similar in that they are both fixed size and cannot be resized after allocation, but C++ arrays lack built-in length and bounds checking without standard array. Got it. Slices in Go versus vectors in C++. A slice is a dynamically sized, flexible view over an underlying array, allowing for resizing with the append function. Slices include length and capacity metadata, which Go uses to manage memory and determine when to resize the underlying array. Slices are dynamically sized, flexible, cool. It's dynamically sized, much like slices in Go in terms of flexibility. Unlike arrays, slices are okay. Unlike arrays, slices are reference types, meaning they don't copy data but rather refer to an underlying array, making them efficient for passing to functions and manipulating parts of Go. Size. I should have selected this from the beginning. Fixed, contiguous, yes, decays to pointer. Part of type, no. Oh, I'm getting tired. Alright. Coolio. I think I got about, yeah, the slices is where we're gonna leave off, and then we'll hit tomorrow with what? Get out of here. Dot cache get status. Cool. All right, stream. I think we're gonna call it because I'm kind of brain fried right now. On top of this, I work a 9 to 5, so I'm kind of all burnt out of learning today. But we'll probably hit it tomorrow or sometime next week to learn more about Go. So if you're a part of the stream, thanks for tuning in. If not, we'll hopefully catch you in the next one. And yeah, it's been fun. It's been real.